Hi, welcome to an Arduino step-by-step course by Robojax. Arduino has analog inputs, and Arduino Uno, this board that we are using, has 6 inputs. And the difference between analog and digital is that in digital we have discrete values of low or high. When we work with Arduino, the value for high and low have been defined according to the following diagram. I'm going to explain it. So this is the 0 in terms of time, and that is the amplitude or voltage. And there are 2 types of board that you use from Arduino. Arduino Uno that we are using uses 5 volts, but Arduino Mini and Nano, you can select your voltage, and some other boards as well. When you're using 5 volts, and at 5 volts, between 0 to 1 volt is defined as low, and any voltage between 3 to 5 volts is high. Something in between is unknown, and Arduino will just ignore it. So the value must be between these ranges. But internally with Arduino, when you set it high, you always get 5 volts, and when you set it low, you will get 0. So this definition applies when you connect it from external source to Arduino, and it must abide by this rule. And in case if you're using a 3.3 volts, which is another industry standard voltage with majority of microcontroller and CPUs, then in this case, the maximum, the high it goes up to 3 volts, and for high, the voltage between 2 to 3.3 is considered as high, and from 0 to 1 volt is considered as low. Analog can be used to measure between 0 to 5 volts because the maximum input that this device can accept at these pins are 5 volts, and it can measure between 0 to 5 volts. In terms of 5 volts, if we have a signal, a voltage fluctuates and goes high and then goes back to this and goes up and down, we can read at any moment at every step of this. And for example, if we have a signal that goes maximum to 5 volts, which is the voltage for our Arduino Uno that accepts as an input, then we have to break this down, and we have something called analog to digital converter, and it breaks it and measure different value of it as a digital value. And in Arduino Uno, we have it with the 10-bit resolution, which means 2 to the power of 10 at 1024 steps. From here to here, it breaks it up to 1024 steps and checks and records the value for us. So we will have between 0 to 1023, in total 1024 steps. That's called 10-bit analog to digital converter. So this is analog, and this can accept analog input. For analog input, you cannot connect or get the value from there. For example, the potentiometer, or this is a variable resistor. I'm going to put the knob here. So let me put the knob. You will see it on many devices that you can increase the audio volume of audio, or some speed of motor or something with this knob. Internally, this is a variable resistor. This variable resistor, or sometimes people call it potentiometer, has 3 wires or 3 pins. I've connected here 3 wires. But if you receive it, you will get it something like this without wire. I've soldered the wire here. This is a variable resistor or potentiometer. It's shown on diagrams like this. This is actually a resistor, and this point at the middle is a sliding piece that goes either to the left or right. When you move it to the left, it becomes the same value as whatever is at A pin, and if you're somewhere at the middle, you will get half of the value, and if it is to the right, it will go to the B. And this is what is inside this variable resistor that I have. On this side, so this is the resistive material, and this is a wiper that goes in between. This is a 100 kilo ohm variable resistor. and this is a 10 kilo ohm variable resistor, and it can be rotated. So let's say if this is 100 kilo ohm, if you put your multimeter between point A and point B, you will get 100 kilo ohm from here to here. That's as if you put multimeter between this point and this point. This will not change. It will be fixed. But if you want a value between 0 and 100 kilo ohm, in this case, if this is 100 kilo ohm, if you bring this to the left, you will get 0 ohm, because at this point it's 0 and slowly it increases. At the middle it will be 50 kilo ohm, and this will be 100 kilo ohm. So if you get between A and C, if you put your multimeter, bring this to the left, it will be 0. And slowly, if you move it to the right, the value will increase. If it reaches here, it will be 50 kilo ohm, and around here it will be 75 kilo ohm, and around here, when this reaches, the wiper reaches to the point B, it will be 100 kilo ohm. With this one, we can get different value of resistance, and the resistor will act as a voltage divider, and you will get different voltage. If you found this tutorial helpful, please thumb up, and also click on the subscribe on the right side in the lower corner. I really appreciate it. Here are other types of potentiometer or variable resistor. This is called precision multi-turn potentiometer, because you can turn it multiple times before it stops. This is 10 kilo ohm plus minus 5%. Or maybe you will see it something like this. And this is the middle pin, exactly like the other one, and these are the two other pins. This has been labeled as 503, so 50 and 3 means 30. This is 50,000 ohm or 50 kilo ohm, and these are the two main pins. When you adjust it using a screwdriver like this, you get the result from this middle pin. Or you will see a potentiometer that is installed like this, flat, and it can be adjusted using a screwdriver. For example, in this case, this adjusts the intensity of this light of this display. Or you might see it something like this, which is standing, and you can adjust the voltage or some other parameter using potentiometer. This is also multi-turn. You have to turn it 10-15 times before it reaches the end. And the value for this one is 103. The 3 means 30. This is 10 kilo ohm. So this is an example. Let's say if we connect this, the A to 5 volts, B to ground, and C, measure the voltage as at this point, C at the middle. So if we set the variable resistor at the middle, that we have 50 kilo ohm on one side and 50 kilo ohm on the other side, so this will be at the middle, then the voltage will be half of 5, because we have 50 kilo ohm here and 50 kilo ohm here. The voltage will be divided on between the two resistors, and if you measure the voltage between ground and the point C, this will be half a voltage, and if we measure between these two, it will be half. But in Arduino, we always measure with respect to ground, so one side is here and one side is here. So in this case, we are measuring 5 divided by 2, because these are equal. We just put divided by 2, and it will be 2.5 volts. Here I have connected 4 1 kilo ohm resistors from this point to this point, and from here they are in series connected. This point is connected to 5 volts in Arduino, and this point is connected to ground, so 5 volts to ground. At this point, we do at the top, we do the total, which is 4 kilo ohm, 1 plus 1 plus 1, 5 times the sum of all divided by sum of all. And because the top and bottom is 4 kilo ohm, they cancel each other, and the voltage is 5 volts. And at this point, we do 5 multiplied by sum of this point to the ground, which is 3 kilo ohm, divided by sum of all, 4 kilo ohm, 3.75 volts, plus 1.25, which is 3.75. And at point C, we will get 2.5 volts, 2 divided by 4, here multiplied by 5, it will be 2.5. Then at the point D, we will get 1.25 volts. 5 multiplied by 1 kilo ohm divided by sum of all. At this point, in one of them, you will read 1.25. Let's get started with the wiring. So on this side, I will connect on the left one to the ground. And then this, on the right side, I will connect it to 5 volts. I've also put a red tape around this. Make sure that you must connect these two to the different point, not the middle one. If you connect the middle one in the ground or 5 volts, when you rotate it, for example, if you connect this to the ground and connect this to 5 volts, when you rotate it up to here, you're short-circuiting 5 volts. Make sure the middle one is not connected to the ground or to 5 volts. And then this is now connected to analog 0. The first line that we have here, I've defined this analog 0 as a variable called pot pen or potentiometer pen. The type is integer and I set it as constant. When you put constant in front of a variable, usually the variable will be like this, but if you put constant in front of it, it becomes constant, and during the execution of code, the value cannot be changed. If you don't put const, then you can do some calculation or change it or update it. This gives us assurance that the pot pen will always stay analog 0. Inside the setup, when I click from here to here, we initialize the serial monitor with 9600 baud, and then we print this text reading analog value. Inside the loop, from here to here, we first use analog read, and we put the pot pen, which we have defined here. This is as if we type analog 0 here. We use analog read pot pen. It goes to analog 0, reads the analog value between 0 and 1023 and stores it in a variable called pot value, and the type is integer. So this is now holding the value of the potentiometer that we are rotating at analog 0. Then this is just a text. It says pot val or pot value, the value. This is because it has double quotation. It's just a text. And then immediately after that, this will be printed. This is a variable because it doesn't have any quotation, and that is this variable. So we will print whatever we are rotating using potentiometer. The value between 0 and 1023 will be displayed after this. Immediately after, with a space, we print the text voltage with colon. This is again a text. After that, we get the pot value multiplied by 5 divided by 2023, because we have 2023 steps. And you see here this float. Every time you are working with a value that has decimal point, we define it as a type float. And this is a variable, we call it voltage. You can type V or whatever you're pleased with. So the result of this calculation will give us the actual voltage, which we store inside this voltage variable. And then we print this voltage. After that, in order to make it nice, we print V at the end, and this has ln. The others do not have ln because we don't want this text to be beneath that. We want all of them in one line. But here, when we put the V after this, the next text will come. This will create a new line, so they will be displayed in the next line. And then we wait 200 milliseconds, and this continues like that. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. Now let's demonstrate it. My Arduino is now connected. First, make sure the port is selected, and after that, just upload the code. And I will open the serial monitor here so you can read the voltage. Now this is completed. The upload have been completed, and this is the pot value. This value is this, at the moment what is reading at pin analog 0, and the actual voltage referring to this is here, 0.2 volts. Now if I rotate this slowly, this is the actual voltage. In your daily usage you will not need it. I'm just doing it for demonstration to see the relationship between these values. So it's now around 1.1 volts. If I go at the middle, you will get around 2.5 volts. This is approximate. And then if I go 1/4, this is if I go 3/4, we are getting around 4 or 3.75, and then fully, if I go fully, I get 1023, and that is 5 volts. Now, how can you use this voltage for some application that you need? Now, for example, you want to take action based on voltage. Let's say you want to check the voltage. If the voltage is equal or greater than 2.8 volts, this is just an example, do something. Whatever you do is between these two curly parentheses is this one, but you can have more actions. For example, if the voltage increases, you can turn on a relay, turn on a motor, a fan, a heater, whatever, or a charger. This is just for demonstration purpose. We just say voltage is above 2.8 volts, and let me upload it. Now the voltage is around 0 volt. I'm slowly increasing it, as you can see. 0.6, increasing 1 volt, 1.25, 3, 1.6, 1.7, 1.8. Now it's 2 volts. So we will be reaching at 2.8 and above, then you will see it. So when the voltage reaches 2.89, you will see voltage above 2.8. This is just the result of the condition that we set there. Now if I go up, it is above and it's valid. Now I've set this that if the voltage is above 2.8 volts and below 4.1, this will print this condition, this text for us. So how we do it is we say if the voltage is equal or greater than 2.8, and these two ampersand mean and voltage is smaller or equal than 4.1. So this condition and this condition must be true in order to execute this text or command, whatever you type here instead of this. Let me open the serial monitor. The code is uploaded. So I will decrease it slowly until it reaches 4.1. As soon as it reaches 4.1, it says the voltage between this and this, 2.8 and 4.1. If I go lower, now read this line, it's 3.51 until it reaches 2.8. Now it's around 3 volts, 2.95, 2.84. As soon as I go below 2.8, which is 2.7, that extra text that was showing and disappeared. So this way you can use the condition and reading the voltage to take some action. Now in this sketch I've updated it so we can read the value of resistor. It shows the voltage and it shows at a certain point that you set it what is the resistor value between the ground and that point. So the first thing that I've done is we have to know the value of potentiometer. In this case, this is a 10 kilo ohm. And the B, by the way, at the beginning, B mean linear. For our case, this is linear, which means if this is 10 kilo ohm, the middle will be 5 kilo ohm and so forth. But for audio and for other logarithmic types, we will have A and other letters that is corresponding to those. So B means linear. First RT, that's the total of potentiometer, 10 1000 ohm or 10 kilo ohm, so we put 10,000, and this R, both of these have been defined as float here. After that, this is the only line that I've added, voltage multiplied by RT divided by 5. So this calculation will be stored in R, which has been defined above. This is the R value, and we say R, and then we put R, and then in ohms, and then the voltage. Everything else is the same except I've added this line and removed the pot value. I've uploaded the code. Let me open it. Now it shows it's around 2.8 volts, and R is 5600 ohm. And if I go all the way to the right, you will see it shows 10,000 or 10 kilo ohm, and it shows the voltage 5 volts. And if I come somewhere in here, 1.8 volts, so that's 3,500. If I come to the left, it's 0 volts, is 0 ohm, because it's now a short circuit between this pin and this pin. So if I go, let's say you want 1 kilo ohm, slowly increase it until it reaches 1000. This is 1000, and the voltage is 0.5 volts. And if you see, if this is 1000, 0.5 multiplied by 10, 10 of 0.5 is 5 volts, so it makes sense. 5 kilo ohm, 2500. Now it's 2500, and the voltage is 1.25 volts, and we are here at the quarter value of this. Please make sure to subscribe by clicking at the subscribe button in here. Thank you.